All right. In this video, we're going to go over making projectiles and then spawning them with an animation notify. So already I have open a PaperZD character called projectile base. I've stored this within an effects folder, projectiles, projectile base. And once again, that is a blueprint class PaperZD character right there. We open it up. The reason we're going to use this is because we gain access to the animation component, which can allow us to potentially create projectiles that have their own animation blueprints so they can change animations and such. Next thing we need to do is under here, we see I have a projectile movement. That was just add component, search for projectile movement. Now with the projectile movement, we want to do a few things. We want to set the initial speed to be 1,000, and then I like to set the gravity to be 0, so the projectiles won't be pulled to the ground, at least not yet. Now this blueprint class will be the parent to all projectiles, so all of these settings will be passed down to its children. Okay, now we see here I have an event hit destroy actor. Now what this is when the projectile interacts with a object that is blocked by collisions. We can hover over here. So if it interacts with within its collision presets, it hits something that blocks it, it will then fire this event and it will destroy the actor. Now we want to actually change those collision presets, so we can search up collision. And we'll see here that I have a preset called projectile for both this collision and this other collision. Now I have made this collision preset. However, you can go into custom and pretty much set everything to be the same. But I will show you how to make a custom collision. So we just need to go into edit, project settings, scroll down to collision. We need to add an object channel, name it projectile. When you do know object channel, you can name it projectile and then leave the default response to block. Open up preset, add a new preset, name it projectile, collisions, where is it? Enabled. We want the object type to be projectile. And then we want to change a few things. You probably won't have this ignore all. I'm pretty sure I made this a long time ago, so you can ignore that. We'll change the cameras to be ignored. This stops projectiles from overlapping or blocking cameras, which can cause flickering. And then we want to change pawns to overlap. This will be how I handle applying damage. So, like I previously mentioned, should the projectile interact with any of these that are blocked, like world static, so it's going to be our tile maps, or any of these right here. I guess it's also projectiles. We can leave that for now. I guess projectiles might be able to collide. That's kind of... We'll have it ignore other projectiles for now. Should it block with any of these, it will generate that hit event and it will destroy the projectile. And then should it overlap a pawn, it will create another type of event called an overlap. And then from there, we will be able to detect if we should apply damage or not. Perfect. So that will be projectile collisions. And we can see that here. I probably should change mine. I just thought of that. That might... that might make some funny little projectile interactions. But that's all right for now. So both of these collision presets will be set to that newly made projectile. Perfect. Next, we need to move on to the actual notify. So I guess before that, let's create a child blueprint. I have something like an arrow. I've made an arrow flipbook. Within here, we have just set the sprite to be that arrow flipbook, and nothing else has been changed within here. You'll see I have a few other things like interfaces and such, and then within here I actually have some more code that will be for later in another video when we go over teams. Okay, so Once you create some type of a projectile, we need to make a spawn projectile notify. So that's going to be blueprint class, PaperZD notify, and we're going to grab that right there. Opening that up, we'll need to make sure we get the function for onReceiveNotify. That will probably be in the override. We want to do a validity check. Now, if you haven't seen my video over Notifies, the reason this validity check is important is it actually offers us a way to not only see the notify happen within the world when it's valid, but if it's not valid, to also see it within our animation source playback device. So the next thing we're going to do is get the sequence render components. That's just get sequence render component. What the sequence render component is, it's just essentially what's rendering in these sequences, both in the source and within the world itself. So from there, we need to do a couple of different little math. So the nice thing about the animation notifies is any variables we add, as long as they are not local variables, if they are regular variables, they will show up within the notify, and you can add notifies by adding a track. You can insert tracks, you can add tracks, then right click, add notify, and then add your notify where you've made it. We can see these variables though as they appear in here. And you can actually go a little bit further and add in categories, and it will create drop down menus within here for different categories if you have a lot of different variables. So the variables we're going to care about is an offset, a rotation, and a scale for right here. The offset needs to be plugged into a rotate vector based off of the world transform. And when you get world transform, you're given this, which you can right click. You can right click to split and gain access to all of those. And so we need to rotate the vector based off of the rotation of the render component. This will allow us to, when our character turns left or right, it will properly rotate any offset that we add to where our projectile will spawn. So it makes sense when we actually start to change things like offset. Then we need to get the returned value of that and multiply it by the render component's scale. Now this is a bit of an interesting one. So the render component, its scale is tied to your character's scale. So if I come in here to my adventurer blueprint, viewport, we'll select him. This sprite has a scale of 5.3. This render component, when utilized by this sprite, will also have a scale of 5.3. So we need to factor in that scale into our offset. Otherwise, our offset will appear reduced in context of the actual world, because the animation source doesn't account for that scale of 5.3 in the real world. So this right now is actually a very, very small sprite. Then when I spawn it into my world, I've had to scale it up to make it fit into the capsule component and be a little bit more visible. So if we don't account for that, our animation source, if I were to just plug this in right here, I can come in here and I'll change my offset. My animation source will show this spawns in somewhere, but in reality, it'll be kind of hard to see. Actually, I'll just do this right here. Set game. Sorry, this is a debugging tool. Do this. Set game pause to be true. We'll see that the projectile is spawning farther inside of our sprite than where we would want it. Even though I have set it using some debugging tools, which we'll show, to be over here, it's spawning inside of the character, which we don't want. And that is just basically because of the scale not being accounted for. Okay, perfect. Now we need to get the rotation, combine rotators for a rotation variable. This is going to allow us to change the rotation within our source. And then we're going to get the scale, multiply a scale variable by the sequence render component scale. And then we're going to make a transform of all of this. That transform will be used in a spawn actor. The class will be a class variable. And we see that this is the same for both is valid and is not valid, with the only difference being some things up here that will be covered in another video over Teams. And then down here, I have a branch with a debug variable. We get a component by class, the class being paper flipbook component. We get the component's bounds, and we draw a debug box off of those bounds and rotation. So what essentially we're doing, by getting a component's bounds, we're coming in and we will get the bounds of the paper flipbook of this right here. So if I come in here and look at this arrow, we're getting this component right here, which is our paper flipbook component, and we're getting the bounds, which is the size of that component. So that will give us a very quick and easy way to know how large the component and the actual sprite contained within it are. Then if we go into an animation source and actually add that notify, we gain access, like I said, to all of these different variables. We can change the class here. I could change it to a fireball. And I'll shoot a fireball. I have my debug variable, which the reason we have that is it allows us to see where this is going to spawn. Without that, it is quite difficult to tell exactly where it's spawning, as this moves very quickly. I've come up with other solutions to freeze this, but they were all a bit gimmicky, and I have found that this works best. I'll go back to my arrow. Oh, whoops. No. I don't want planar reflection. That's kind of funny. I might have. Hopefully that doesn't break things. Perfect. I might actually just close out of this real quick. I don't like that being there. All right. Going back to the bow. So we'll see that with the offset, we can move it around. I can move it to 10. That moves it in. Move it back to 20. I can lower it. I can raise it. Or I can put it back where it was. We can change its rotation. Why this is important is there are times in which we have sprites that face in the opposite direction. And so without a way to account for rotation, we would have a bit of a weird projectile. It would shoot the projectile, but then it would go backwards in the context of this character. So we can rotate that backwards. And then, yeah, that should be about it. We don't deal with damage numbers within here. That will all be dealt with within the projectile base. However, I'm not going to cover that right now, because before I do that, we have to go over interfaces to create a team system and health components to actually create health that we can damage. So that should be it for this video. I hope that makes sense. And yeah, I mean, the only other type of thing, I guess, is scale, which I didn't really mention. You can change the projectile scale. This one I have to make half as big, because otherwise he shoots really big arrows. But yeah, that's about it. So if you have any questions, feel free to ask as always, and good luck.